All right, here are a few substitution examples from the worksheet that we worked on Friday. Specifically, this is 9 and 10. So let's take a look at number 9 here. So the first thing that I'm going to do is I'm going to label my two equations, so equation 1 and equation 2. And I'm going to start with the simpler equation. Now, if I look at equation 1 here, I can see that I can pretty easily rearrange for y. And so I'm going to start with equation 1. So I'm going to rewrite equation 1 down here, plus y equals -2. And I'm going to rearrange this equation for y, which means I want to take the -5x and bring it over to the other side. And so I have y is equal to, now when I move -5x over to the other side of the equation, it'll become positive 5x. So I will have -2 plus 5x, or I could have rewritten that as 5x minus 2. Okay. Now that I have one of my variables rearranged, I want to substitute this back into the equation that I didn't choose. So in this case, I didn't choose equation 2. So now that I've rearranged equation 1, I'm going to substitute this into equation 2 for y. So I have -3x plus 6 times 5x minus 2 equals -12. And now I have to expand this out. Okay, so I have to get rid of my brackets, I have to simplify it, and I have to rearrange for x. Okay, so I'm going to get rid of the brackets here by distributing. So I get -3x and then plus 30x and minus 12 equals -12. Now, because I have -12 and -12 on both sides of my equation here, so -12 on the left-hand side and -12 on the right-hand side, if I bring this -12 over, it becomes addition. And so they'll just cancel each other out, right? So that's one cool thing. When you have the same number on both sides of the equations like this, they will just cancel each other out. So I get 27x is equal to 0, which means that if I divide both sides by 27, I get x is equal to 0, which is kind of interesting, right? We didn't see an example quite like this on Friday. Nonetheless, we have our x value. Now here comes the back substitution part of this. I found one of my solutions, so I found the solution for equation 2 here. I have to substitute this back in to equation 1 to figure out what my y variable is. So I have y is equal to 5x minus 2, and instead of x, I'm going to write 0 because that's what I found x to be. So I get y is equal to 5 times 0 minus 2. So 5 times 0, that's 0. Therefore, y is equal to -2. And so my answer is, so therefore, the solution of the linear system is 0, -2. Okay, so x is equal to 0, y is equal to -2. And that's it for that question. So now let's give 10 a try. So again, here I'm going to move 10 over a bit. Again, I'm going to label my two equations, so equation 1 and equation 2. And I'm going to start with the simpler of the two equations, which again looks like it's equation 1. So let's rewrite equation 1 down here, and we'll rearrange for y, same as we did for question 9. So 5x plus y is equal to -3. We're going to move the -5x over to the other side. And when I do that, it becomes positive 5x. Actually, looking at this equation, the previous problem, it looks actually pretty similar. So we get y is equal to 5x minus 3. And now I'm going to do my substitution step. So this is my rearranged equation 1. And now I'm going to bring down equation 2, and I'm going to use my substitution. So I have 3x minus 8y equals 24. And again, I notice that I have my y rearranged already, and I have y in this equation. And so when I plug in, I get 3x minus 8 times, and then I have 5x minus 3 equals 24. So I get 3x minus, now I have to be really careful with my positives and negatives here. So notice that I'm bringing a negative 8 inside my brackets here. Okay, let me make my highlighter a bit bigger. So because I'm multiplying in negative 8 inside the brackets, I just have to really watch out for my signs when I'm multiplying my integers. So I have negative 8 times positive 5x. So when I multiply those together, I will get negative 40x. And then I have negative 8 times negative 3. And so when I do negative 8 times negative 3, I will get positive 24, because a negative times a negative gives me a positive, equals 24. And again, I notice a strange circumstance, because I have 24 on one side of my equation and 24 on the other side of the equation. And so again, when I try to move this 24 over to the other side, they're just going to cancel each other out, right? Because I get 24 minus 24. And so what I'm left with is 3x minus 40x. And then there's just nothing on the other side because the 24 is canceled out. So then I get 3x minus 40x, that's negative 37x equals 0. And the only way that that works, if I divide both sides by negative 37, 0 divided by anything is still 0, so I get x is equal to 0, just like I had in the previous question. So we definitely see some similarities between question 9 and 10. Now, I can go back and substitute back into my y equation here, right? So the equation that I developed from equation 1 for y. So from equation 1, I get y is equal to, oops, let me switch back to black ink here. Y is equal to 5x minus 3. And I'm going to substitute in x is equal to 0. So y is equal to 5 times 0, that's gone, minus 3. So y is equal to negative 3. And that's my solution. Then I can summarize. So therefore, the solution of the linear system, or of the system, is 0, negative 3. And that's about it. So two pretty similar examples, but definitely a little bit different than the types of questions that we saw on Friday.